Hi to all. Today I am going to start the next chapter, that is ninth chapter, Ray Optics. Ray Optics and Optical Instruments. This is my chapter and now I am going to explain the first topic in the ray optics, that is refraction. Refraction I am going to start. What is refraction? And now refraction means, this will occur in the 10th class also, you know that is when the light ray moves from one medium to another medium. Its speed is changes when it enters into other medium and its direction of motion also changes. The phenomenon of bending of light at the separation of two mediums is called as refraction. Look at here, this is the surface separating the two mediums. This is a boundary which surface separates the two mediums. Above this we can consider as the medium 1, and below this medium 2 is there. There are two mediums, different mediums. And now this is the surface separating the two mediums. And now let us consider, this is the normal drawn. This is the line. This makes 90 degree with the surface, right? This is the surface separating the two mediums. For example, this is the air, okay, and this is considered as the water. There are different mediums, okay. Medium means a substance, and this is the normal drawn. For example, this is O, okay, this is N. ON is the normal drawn. Normal drawn means it is a line, it is perpendicular to the surface, that is a normal drawn. For example, the light ray is incidenting like this. The light ray is incidenting like this. This is the incident light ray, right? Then we know that the light will travel in straight line path in one medium, right? And this is considered as incident light ray. This is considered as IO. IO is the incident light ray. And if there is no change in the medium, the light will travel with the same speed in the same direction. But when the light is moves from one medium to another medium, it cannot travel in straight line. It can bends either towards the normal or away from the normal. For example, here this is original path and now it is bends towards the normal. This is the normal, right? And this red line is the normal, and now it is bending towards the normal. Look at here, this is the original path and it bends like this. This side it is bending means that is bending towards the normal, and this is called as refracted light ray. OR is the refracted light ray, and this angle is called as angle of refraction, and this angle is called as angle of incidence. Okay, and from the figure we write some data. Before that, what is refraction we write? What is refraction? The phenomenon of bending of light. What is the refraction? The phenomenon of bending of light. The phenomenon of bending of light at the separation of or at the boundary of two mediums, okay. When light moves from one medium to another medium, it bends at the separation of two mediums. This phenomenon is called as refraction. The phenomenon of bending of light at the separation of two mediums is called as refraction. If you go with some terms in the refraction, then what are the terms? IO is called as incident light ray, right? Incident light ray. And this IO and OR is called as refracted light ray. And I is called as angle of incidence. What is I? I is the angle of incidence. Angle of incidence is angle between what and what? Incident light ray and normal drawn, right? I is called as angle of incidence, right? Angle of incidence. R is called as angle of refraction. What is NO? NO is called as normal drawn. normal drawn to the surface, right? For example, we take this as x dash. This x dash is what from the figure? X dash is the boundary of two mediums, right? Okay, boundary of two mediums. Above the boundary we have the medium 1 and below the boundary we have the medium 2. And now this is about what is refraction and what are the terms related to the refraction. And now we have to go for the laws of refraction. What are the laws of refraction? Laws of refraction. What are the laws of refraction? The laws of refraction are there are two laws are there. Okay, that is the incident light ray. Incident light ray. Okay, next refracted light ray. Refracted light ray and normal drawn are in the same plane. Normal drawn are in the same plane. This is the first rule, right? Laws of refraction. What is the meaning of this? This is the incident light ray, this is the normal drawn, and this is the refracted light ray. All are in the same plane. Same plane means all are in the same surface. Okay, that means it is incident light ray and normal drawn are in which plane? The refracted light ray also in the same plane, in the same surface, right? And now if you go for this diagram, and incident light ray, normal drawn, refracted light ray, all are in the board plane, right? Board surface, single surface, confined to one plane. The second law is that is the ratio between sine of angle of incidence to the ratio between sine of angle of incidence, sine of angle of incidence and sine of angle of refraction, is remains constant. This is the second law, is remains constant, and it is equal to the refractive index of second medium with respect to first medium. Here I wrote the WRT, that means with respect to first medium, or this is also called as relative refractive index. This we can write in sentence equation form. What I am telling it here, ratio between sine of angle of incidence. Sine of angle of incidence is a sine of angle of incidence by sine of angle of refraction is remains constant. This constant is equal to refractive index of second medium with respect to first medium. This we can written as 1 mu 2. This is the mu is the symbol, this is the mu. Okay, and 1 mu 2 means mu 2 refractive index of second medium with respect to first medium. This we can write like this. Okay, and this is the what? Second law. What is 1 mu 2 in this? 1 mu 2 is the refractive index of second medium with respect to first medium, or it is also called as relative refractive index. That is also called as relative refractive index. And now this has one name. Okay, the second law is also called as Snell's law. Okay, this is also called as Snell's law. Okay, It gave this law is given by the scientist Snell. That's why on his name it is also called as Snell's law. Take the screenshot and note it, and I will continue. Okay, now let us see continuation of the last topic, that is where we are now. Second law, laws of refraction, is completed. In the laws of refraction, finally we have the second law. In that one equation we got, what is that? Sin A by sin R is equal to 1 nu2. In that 1 nu2 is called as refractive index of, what is that? Refractive index of second medium. Refractive index of second medium with respect to first medium. With respect to first medium. And or it is also have one more name, that is called as relative refractive index. Relative refractive index. Relative refractive index. How to find out this? And what is this? This we wrote as 1 mu 2. That I want. Okay. And I want the refractive index of second medium with respect to first medium, or relative refractive index. It has some other name, that is the relative refractive index, because it is a refractive index of one medium with respect to another medium. Let us see here. For this purpose, what we have to do it here, it is the 1 mu 2 is the refractive index of second medium with respect to first medium, right? This we can write as, it is the definition of this one is, it is the ratio between speed of light in first medium to the speed of light in second medium. Is called as relative refractive index. Relative refractive index or refractive index of second medium. Refractive index of second medium with respect to first medium. This is the formula, it is a definition for the refractive index of second medium. In Snell's law, previously in the second law, what you got here, sin A by sin R is equal to 1 mu 2, where I is the angle of incidence, R is the angle of refraction. 1 mu 2 is called as refractive index of second medium with respect to first medium. It is also called as relative refractive index, that is 1 mu 2. 1 mu 2 definition is the ratio between speed of light in first medium to the speed of light in second medium. That means what? For example, this is the medium 1. Okay, this is the medium 1 and this is the medium 2. And here this is the line separating the two mediums. And now let us consider the light is trying to move from this the normal run, and the light is trying to move from first medium to second medium. The light has the v1 speed in the first medium, and after entering into the second medium, its speed will become, for example, v2. And in the first medium the light speed is v1, in the second medium the light speed is v2. The ratio between these two speeds is equal to refractive index of second medium with respect to first medium. That means 1 nu 2 formula is there. 1 nu 2 formula is speed of light in first medium by speed of light in second medium. That is the 1 mu 2 is equal to, what is the formula? Speed of light in first medium by speed of light in second medium. That is, we write as v1 by v2. This is 1 mu 2. And this refractive index not have any unit. No unit and no dimension. Why no unit and no dimension? Because it does not have speed by speed, that's well, no dimensions and no unit. What is v1? Speed of light in first medium. What is v2? Speed of light in second medium. This is the definition, right? Okay, and now let us go for the one more definition. That is, here we got the refractive index of second medium with respect to first medium. If you want, there is one more formula is also there for the 1 mu 2, right? 1 mu 2 is called as, that is a nu 2 by nu 1 also, okay? Or we can also write 2 nu 1, okay? 2 nu 1 also we can write. What is 2 nu 1? Here we wrote the refractive index of second medium with respect to first medium, and we can also write refractive index of first medium with respect to second medium also. How we can write that one? Here we got 1 mu 2 as v1 by v2, okay? This formula we can also write like this, that is 1 mu 2 is equal to mu 2 by mu 1. But what is mu 1 comma mu 2? Mu 1 comma mu 2 are called as absolute refractive index. Absolute refractive index. Nu 1 is the absolute refractive index of first medium. Nu 1 is the absolute refractive index of first medium. Absolute refractive index of first medium. And mu 2 is the absolute refractive index of second medium. Absolute refractive index of second medium, okay? Then what is absolute refractive index? Let us go for the next one more definition. That is, absolute refractive index is what? Okay, it is a relative refractive index. Relative refractive index means refractive index of one medium with respect to another medium. But I want the absolute refractive index. Absolute refractive index. What is absolute refractive index? Okay, refractive index that depends upon only one medium. Absolute refractive index of medium. Certain medium, absolute refractive index is what? This is mu, okay? Then its definition is the, what is absolute refractive index? Refractive index of any medium with respect to vacuum is called as absolute refractive index, okay? Or otherwise we can also define like this, that is here we have the relative refractive index 1 mu 2, okay? 1 mu 2 we have the value 1 mu 2 is the nu 2 by nu 1. For example, I want the glass refractive index, okay? Second medium we can take as the glass, refractive index of glass. For example, with respect to vacuum I want, this we can write refractive index of glass by refractive index of vacuum. But the real value of vacuum refractive index is 1, that's why we will get only refractive index of glass. That means any refractive index of glass with respect to vacuum is called as refractive index of glass. That is absolute refractive index. This is called as absolute refractive index. It does not depend upon any other medium, okay? I will also define in another manner, don't be confused, okay? I will define, okay? You read all the formulas. And now, what is absolute refractive index? It is in definition, in easy manner I will do, right? The ratio between speed of light, the ratio between speed of light in vacuum, okay? Speed of light in vacuum and or to the ratio between speed of light in vacuum to the speed of light in medium is called as absolute refractive index of medium. Absolute refractive index of medium. That does not absolute means it does not depends upon another medium. Here relative refractive index means the refractive index of one medium depends upon other medium, but here absolute refractive index of medium means it does not depends upon the other medium. The ratio between speed of light in vacuum to the speed of light in medium is called as absolute refractive index of medium, okay? Then absolute refractive index formula. Absolute refractive index, that is mu is equal to speed of light in vacuum. Speed of light in vacuum. Speed of light in vacuum, that is c, right? 3 into 10 to the power of 8 by speed of light in medium. Speed of light in medium. In medium, the speed of light we can consider as v. Then we write here the absolute refractive index formula is c by v. Okay. What is the value of c at here? We know the c value is 3 into 10 to the power of 8 meter per second. That is the speed of light in vacuum. Okay. For example, I am going to continue. You take the screenshot and note it. Okay, for example, you want the absolute refractive index of glass. I want absolute refractive index of glass. Absolute refractive index of glass I want. That is mu g. Its formula is c by speed of light in vacuum by absolute refractive index of certain medium is equal to speed of light in vacuum by speed of light in that medium. That means if you want to find out the absolute refractive index of glass, you have to write the speed of light in vacuum by speed of light in glass. Okay, right. Here what is c? We know that one already. What is vg? Vg means speed of glass nahi, right? It is not speed of glass, it is the speed of light in glass. Speed of light in glass. Okay, right. What is the value of absolute refractive index of glass? And if you want the absolute refractive index of absolute refractive index of water, if you want, you have to write the new w. It is the absolute refractive index of water. It is the speed of light in vacuum by we write the speed of light in water. What is vw here? Vw is the c is the speed of light in vacuum. Vw is the speed of light in water. Speed of light in water we have to write. Right? In the denominator, in which medium you write the speed, that medium absolute refractive index you will get. And if you want the absolute refractive index of air, absolute refractive index of air we write like this. That is air is equal to speed of light in vacuum by speed of light in air we have to write. V air means what at here? V air is the speed of light in air we have to write. Speed of light in air medium. Speed of light in air medium. And in this c is what? C is what? Speed of light in vacuum. Speed of light in vacuum. Okay? Right. But we know in the practical, right, the speed of light in medium and speed of light in vacuum. Absolute refractive indexes of certain mediums I will give. Okay, absolute refractive index. Absolute refractive index of glass I will write. Absolute refractive index of glass is 1.5, you remember. And absolute refractive index of water is 4 by 3. Okay, and absolute refractive index of air is nearly 1. And absolute refractive index of diamond. Absolute refractive index of diamond is 2.4. These are the values of absolute refractive index. On what factor this absolute refractive index depends? Okay, let us see here. We draw the boxes for these formulas. Right, and these are also some important values. Okay, you have to remember these values. Okay, now I want on what factors the absolute refractive index depends. On what factors the absolute refractive index depends? Absolute refractive index, that is mu, depends upon nature of medium. Okay, different mediums have the different refractive index. Okay, and the medium which has more refractive index, it is said to be denser medium. The medium which has less refractive index, it is said to be rarer medium. Okay, when you compare the two mediums, the medium which has less refractive index is said to be rarer medium and other medium is said to be denser medium. And some important point I am going to give it here, that is, for example, here you want the refractive index of glass with respect to water or something, right? And refractive index of second medium with respect to first medium, we know that. Okay, refractive index of second medium with respect to first medium. What is that? With respect to first medium, what is the formula? Right, that is nu2 1 nu2. This we can write as one formula as nu2 by nu1, right? But the same formula, right, we can write this one like this. In case of refractive index of second medium with respect to first medium is completed, I want the refractive index of first medium with respect to second medium. How to write this? Okay, you see here nu2 means refractive index of second medium with respect to first medium. Here I will write refractive index of first medium I want. Refractive index of first medium nu1 with respect to second medium 2. This is equal to, we write nu1 by nu2 we write. What is nu1 nu2? Refractive index of first medium and refractive index of second medium. When you multiply these two equations, for example, this is equation 1 and this is equation 2, and from here we write the heading note, right? Note we write. In the note you can write the equation 1 and equation 2 if you will do, right? Equation 1 into equation 2 if you will write. We will get 1 nu2 is into 2 nu1 is equal, we will get as nu2 by nu1 into nu1 by nu2. We will get as 1. That means 1 nu2 is equal, we write as 1 by 2 nu1 we write. Okay, right. Let us go for the continuation. That is, I am going to explain one thing, that is, okay, one point I am going to explain, that when light moves from one medium to another medium, when light travel from, or when light transmits from one medium to another medium, its frequency remains constant. Okay, during transmission of light from one medium to another medium, the frequency is constant. That is, the frequency is nu, it is constant. That means we know that is speed of light in vacuum or the speed of light in medium, we write like this. Speed of light in medium, we have the formula, that is V is equal to nu lambda. In this V, nu is constant, that's why we write as V proportional to lambda. Speed changes and wavelength changes. That means when the light moves from one medium to another medium, its wavelength changes, according to that velocity also changes. Velocity of light, speed of light also changes. And now, till now many formulas I said that all formulas are confined. The note, and this is very important point. I am going to give very important point. Till now what we discussed in 20 minutes, that I will give within short period, okay, within one formula. Very important formula, right? Very important. VVIMP I wrote here. Chalo, let us start. Then for the purpose, what I do it here, firstly what we discussed it here, Snell's law we discussed, right? And then I want the refractive index of second medium with respect to first medium, right? With respect to first medium. What is that? Refractive index of second medium means nu2, with respect to first means 1. If refractive index of first medium means nu1, with respect to second medium means 2. Let us write one formula, right? Whatever that we discussed in 20 minutes, that I will give in one formula. Chalo, let us start. 1 nu2 is equal to, right? Firstly we discussed 1 nu2 as, according to Snell's law, sin I by sin r, right? Snell's law, that is the second law of refraction. Sin I by sin r is equal to constant, that is 1 nu2. It is equal to later we discussed 1 nu2 is the relative refractive index. That means relative refractive index means the refractive index depends upon other medium. Then what is absolute refractive index? We write this formula in absolute refractive indices, that is nu2 by nu1. Nu2 by nu1. But what is mu2? Nu2 is the absolute refractive index of second medium. There is one formula for the absolute refractive index. What is that? Absolute refractive index is speed of light in vacuum by speed of light in medium. Okay, right? Or otherwise 1 nu2 formula we can also write directly, that is the speed of light in first medium by speed of light in second medium. Is it right? 1 nu2 equal to v1 by v2. But the speed depends upon wavelength. Then we write here lambda 1 by lambda 2. Lambda 1 by lambda 2. These are the various formulas that we learned today, right? This is the most important formula. If you know this formula, we can solve any type of problem. Whatever that we learned today, that all confined in the single formula. This is that single formula. Then what we write some description at here. What are the terms that you know already very well, that we discussed in today only. What is 1 nu2? That is given in the above. And what is I? Angle of incidence. What is R? Angle of refraction. What is mu2? Absolute refractive index of second medium. Absolute refractive index of second medium. Mu1 is the absolute refractive index of first medium. V1 is the speed of light in first medium. V2 is the speed of light in second medium. Okay, V1 speed of light in first medium. First medium. What is V2? Speed of light in second medium. In second medium. What is lambda 1? Wavelength of light. Wavelength of light in first medium, right? What is lambda 2? Lambda 2 is the wavelength of light. Wavelength of light in second medium, right? In second medium. Okay, this is a single and very important formula. When light moves from one medium to another medium, what will changes? Light will bends. Okay, and due to that its speed will changes, wavelength will be changes. Okay, when light goes from one medium to another medium, then how the wavelength changes, how the velocity changes, and how angle changes, that all things we can find out by using this single formula. Okay, right. Now Let us continue some important point, one more important point I am going to explain. What is that point? Now the which is rarer medium and which is denser medium, and if the light travels from rarer medium to denser medium, what happens, and denser to rarer, what happens? Now the light is traveling, firstly we will discuss, that is light travel from rarer medium to denser medium. Light travels from rarer to denser medium. Rarer to denser medium. What happens? When light travels from rarer medium to denser medium, what happens? That I am going to explain. When light travels from rarer medium to denser medium, look at here, this is the rarer medium. Rarer medium means it has less refractive index, absolute refractive index is less, and denser means it has more refractive index, mu2. We write that mu1 less than mu2, we write. This is the normal drawn. What is this? Normal drawn. What is this? This is the boundary which separates the two medias. Okay? And now the light is incidenting like this. Light is incidenting like this, and this is the angle of incidence. And now if there is no change in the medium, then it can go in straight line, and here due to the medium it will bend. It is bending towards the normal. This side it is bending. Look at here. Now actually the light should travel in the straight line like this, but it is bending towards the normal. Okay, and this is said to be refraction. Now this is the angle of refraction. Now when light travels from rarer medium to denser medium, it bends. It bends. Okay, actually it is trying to go in straight line now, but it is bends. How it is bending? It is bending towards the normal, right? Right. This is actual path of light ray. It bends this side. This red line is the normal run. It is bending towards the normal. It will goes like this. It bends towards normal. In this case, rarer medium means it has less refractive index. mu1 less than mu2. mu1 less than mu2. Rarer medium, the medium which has less refractive index, it will act as a rarer medium. The medium which has more refractive index is said to be denser medium. That means mu2 value is more, that's why it is denser. This we can also write like this from this. That is, from here we write mu2 greater than mu1 also, right? And this we can write as mu2 by mu1 greater than 1. Okay, mu1 into 1 we write. Nu2 1 taken left side, then nu2 by nu1 greater than 1. This indicates that 1 nu2 greater than 1. Right? This is the case where 1 nu2 is greater than 1. And now, what about the angle of incidence and angle of refraction? Here we write angle of incidence. Angle of incidence is greater than angle of refraction, or the angle of refraction is less than angle of incidence in this. In this, angle of refraction is less than angle of incidence. Angle of refraction less than angle of incidence. Angle of incidence. Here we write R less than I. R less than I. What is the deviation angle? How much angle it will bend from its original path? This is the deviation angle, right? This is the deviation angle. And here we write the deviation angle. How much angle it is bending? Okay? The deviation angle. Deviation angle means how much angle the light bends from its original path. From original path it bends with delta angle. From this straight line, this is straight in extension, this angle and this dotted line and red line, this is incident light ray and normal angle is angle of incidence. This is red line is normal and this dotted line extension is also incident light ray. This angle also angle of incidence, means r plus delta is angle of incidence. Then the deviation angle, from that we write delta is equal, this total angle is I, from this you remove this, you will get this part. Delta is equal to, we write as I minus r. Okay, delta we write as I minus r. That is the deviation angle, angle through which the light bends. Angle through which the light bends. This is the case when light goes from rarer medium to denser medium. From this also we write here 1 nu2 is equal to 1 nu2 we write as sin I by sin r. Here I less than r less than I, that's why 1 nu2 automatically it will be greater than 1 we will get. Let us see one more point, that is light travel from denser medium to rarer medium. If light travel from denser medium to rarer medium, light travel from denser medium to rarer medium, light travel from denser medium to rarer medium, then what happens? Okay, denser medium means it has more refractive index, more density. Okay, when you compare the air and glass, the glass is the denser medium and air is the rarer medium. When you compare the water and glass, the glass is the denser medium, water is the rarer medium. And here the light is traveling from denser medium to rarer medium. This is the surface, okay, boundary, and this is the normal drawn at here. We will draw the same figure. With the blue line we write boundary. This is the boundary which separates the two mediums, and above this we can consider as the medium 1 and below this medium 2, and this is the normal drawn, and here it is, this is the denser medium, medium 1 is the denser medium. Okay, medium 1 this one, and this is the rarer medium, that is medium 2. Okay, medium 2. The light is traveling from denser to rarer now. The light is traveling from denser to rarer medium, and the light is incidenting like this. It is incidenting. Light is incidenting like this. If there is no change in medium, the light should go in straight like this, and this is the incident light ray and this is the normal drawn. This angle is called as angle of incidence, but this is total angle is also angle of incidence. And now but the light bends away from the normal, it will bends away from the normal. This is the normal. When light goes from rarer to denser, it is bending towards the normal, but it is bends away from the normal. This side it will bends. Okay, this is the refractor light ray, this is original path, and this is the angle of refraction. This is the angle of refraction. Okay, and now this angle is said to be, this angle is said to be deviation angle. Actually original path is this one. From the original path how much angle it is deviated, that is the deviation angle, delta, and this angle is I. This part, this is incident light ray, this is red line is normal, angle is angle of incidence, and this dotted line is again incident light ray, this red line is normal drawn, this angle is again I. If like this it is there, here how much angle it will be there, the here also same angle will be there. Here we indicated with the dotted lines, original path. Similarly here also we will get this angle as I. Then I plus delta we will gives R. Then from that deviation angle we will get as I minus R. Right? Here we got delta is Now let us start. Our delta is r minus I, we will get r minus I. Okay, right. Now let us start. When light ray moves from denser medium to rarer medium, it bends away from the normal. Away from the normal. Okay. Here we write r greater than I, or we write here the first medium has more refractive index, denser medium. Okay. Second medium has less refractive index. This is nu1. And here we write one thing, that nu1 greater than nu2, or we write nu2 less than nu1 we write. Okay, this we can write as nu2 by nu1 less than 1, and here we write as 1 nu2 is less than 1. This is the case, 1 nu2 is less than 1. And here we can also write one thing, that angle of refraction in this case, right, this angle is the angle of refraction. It is more than, angle of refraction is more than the angle of incidence. Angle of incidence. We write r greater than I. R greater than I. If you want the deviation angle in this case, deviation angle, what you will get? That is delta. That is, from this total you can remove this part, you will get this part. Total is r, r is minus I we write. Okay, right, this is the deviation angle. Thank you. In this topic I wrote some little mistake, you remember, you note it, that is the refractive index of second medium with respect to first medium. What I gave, refractive index of second medium nu2 with respect to first medium, I wrote nu2 by nu1, and the refractive index of first medium nu1 with respect to second medium. Refractive index of first medium means nu1, but with respect to second medium means write back 2. Refractive index of second medium nu2 with respect to first medium, that's why back we write 1. This we write as nu1 by nu2. But in the derivation, okay, I wrote little mistake here, you note it where it will comes, and here you write nu1 by nu2, there I wrote nu1 by nu1, and 1 nu2 into 2 nu1 we will get as, you multiply both of them, nu2 by nu1 into nu1 by nu2, this will cancel, and 1 nu2 into 2 nu1 we will get as 1. Okay, you remember this. I wrote the direct step there, that is the little mistake in the writing. Okay, thank you for watching my lectures.